Hi everybody. So in this video, we're going to look at different types of sampling. In the first part of the video, we'll look at random sampling, and in the second part, we'll look at non-random sampling. So if we begin with types of random sampling, and we use the example of choosing students for a group project, in simple random sampling, every student will have an equal chance of being picked. You could put everyone's name into a hat and draw them randomly. It's fair, but impractical for large groups. In systematic sampling, you pick every fifth student on a list. It's quicker, but if a list is ordered, like alphabetically, it could cause bias, and the first person that you pick has to be chosen at random. In stratified sampling, you split the students into groups, like by subject, and you pick a proportional number from each group. This ensures that all the groups are represented, but you need to know the group details first. And each of these three methods require the use of a sampling frame, which we talked about in the previous video. And they've each got their pros and cons, and we're going to work through a couple of real-life examples to show which of these methods would be most suitable. Okay, so in our first example, we're told that a school principal wants to gather the opinions of Year 10 and Year 11 students about the quality of school lunches, and this table shows the number of students in each year group. In part A, we've been asked, suggest a suitable sampling method to take a sample of 50 students. Well, you can see we've got groups. We've got year 10 and year 11, so different year groups, and we've got different genders. So in this case, we would use stratified sampling. In part B, we've been asked to find how many students of each gender in both year 10 and 11 the principal should include in the sample. So we're told it's split into groups, and the proportional samples are taken. So to work out the proportion, we need to find the total number of students in our population. So we can add each of these together and we get 250 students. So our proportion then is 50 out of a total 250. We're looking at this proportion of each of these groups. And with stratified sampling, we call each of these a strata. So to work out the number of year 10 male students, we're looking at this proportion of the 60 students. So this will be 0.2 multiplied by 60, which will give us 12 students. And then for year 11 males, we're looking at the same proportion of the 45 students, which is 9. And then for the year 10 females, we're looking at the 0.2 times 80. And then for year 11 females, we're looking at 20% of 65, which is 13 students. Okay? So now you've got your sampling size for each group, you would use a sampling frame to choose these people at random. Okay, so in this example, use stratified sampling. Let's look at a different example. So now we're told that a supermarket wants to take a sample of its loyalty card members. Each member has a 6-digit loyalty card number, and the supermarket selects every member with a loyalty card number starting in 123. For part A, we're asked, is this a systematic sample? And then to explain our answer. In order to use systematic sampling, the sample must be chosen at regular intervals from a list. And because they're selecting everybody whose number starts with 123, this is not systematic. There's two reasons for this. The first one is that the first person is not selected at random. And the other reason is that members are not being chosen at fixed intervals. For part B, suggest one way to improve the reliability of this sample. Well, you could use the customer's loyalty card number as a sampling frame. Well, depending on the sample size, you could say, using the loyalty card number as a sampling frame, you could use simple random sampling. So for instance, you've got all the members in a spreadsheet, and you could program the spreadsheet to choose your sample at random from that list. Okay? Let's move on to look at non-random sampling. So to explain the different types of non-random sampling, if we use our context again of choosing students for a project, in quota sampling, you decide how many students you need from certain groups, like 3 girls and 2 boys, and then you select people to meet that quota. It's fast, but since you're choosing based on your criteria, it can be biased. With opportunity sampling, this is even simpler. You just pick whoever is available at the time, like the first 5 students who walk into a class. It's convenient, but you might miss out on having a representative group. Both methods are quick, but they can introduce bias, and we need to keep that in mind depending on the context. So again, if we work through 2 examples, in our next example, we're told that researchers at a train station collect data on the travel habits of 50 commuters. For part A, I explain how they could use quota sampling and opportunity sampling to collect this data. So with quota sampling, you would divide the population into groups based on certain criteria, and then you would select people until each quota is filled. With opportunity sampling, you would sample the first 50 available passengers. And then for part B, which method is more likely to produce a representative sample? Well, for this example, you could say quota sampling is likely to be more representative of a passenger population, because you could split the population into different groups. Say, for instance, age and gender. Okay, so let's try one more example. So now we're told a researcher surveys the first 40 people he encounters at a coffee shop on a Monday morning about their exercise habits. For part A, we're asked what type of sampling method he used. For part B, explain why the sampling method might not be representative. And then for part C, to suggest 2 improvements he could make to his data collection technique. So if you want to try this question yourself, you can pause the video, and when you come back, we'll discuss each of these points. Okay, so welcome back if you had a go. So because we're told he surveyed the first 40 people he encounters, this would be opportunity sampling. For part B, because he's used opportunity sampling, this is unlikely to be representative of a whole population. And then for part C, to improve the sampling technique, he could survey at different times of day, and he could survey at multiple locations and use quota sampling to ensure a variety of people. So I hope that's given you a clearer idea on the different types of random and non-random sampling. If you did find that helpful, please like and subscribe, and you can download the full lesson from my website, mrmathematics.com. I'll leave a link in the description below.